Hi, I'm Simon.
And I'm Edward. Welcome to Introduction to Programming.
We're going to learn the fundamentals of code.
We're going to master these fundamentals through fun and creative applications. You're going to be hacking as well as coding from scratch, making art and solving puzzles.
We're going to learn how to code, but we're also going to learn how it feels, what drives coders, and we're going to learn what frustrates them through our code philosophy videos.
You're going to be learning how to hack, you're going to be learning to teach yourself some principles of coding, as well as how to structure projects, debugging and testing. We'll be doing all this using p5.js, but we'll talk about what that is in a bit.
First of all, we're going to tell you a bit about us. So I'm a musician who turned to programming. I taught myself in order to produce the artistic works that I wanted. I've produced audio-visual performances, installations, digital dance works and games for mobile.
And I started programming as a teenager. I was interested in how computers worked and learning how to write my own programs. This led to a BSc degree in computer science, where I grew an interest in how people use computers. And that led to an MSc and PhD in human-computer interaction. I've worked on video and television applications, tabletop touchscreen applications, and data visualizations.
You are also all very different. Perhaps you've learnt some programming already. If so, what language? What environments? What's your educational background? Are you a school leaver or a mature student? Perhaps you're an engineer or an artist or a writer or a linguist. How do you think you could use this knowledge in your code?
We look forward to finding out. Learning to program isn't just about understanding the parts of the code. It's also about having the right mindset. As a programmer, your job is not just as a writer of code, you're also a problem solver. By changing mindset, not only will you learn more about coding and the process of developing software, you'll learn more about the problem you are trying to solve, write less buggy code, and discover more elegant solutions to the task. Please don't believe the programmer hype. If your only experience of programmers is Hollywood films, you would think they are a different species altogether, able to complete the impossible without looking up from their keyboards. It doesn't work like that. Coders are human beings that make mistakes and work through challenges slowly at their own pace. Identifying where and why your code doesn't work is an important part of being able to call yourself a programmer. The best strategy is to be prepared and to fail well. Firstly, don't give up. When code doesn't work, it's time to take off your programmer's baseball cap, put on your detective's fedora, and start to unpick what's going wrong. In this module, you'll learn techniques to help solve errors, as well as to write programs. We'll learn how to minimize and find these errors. We'll also learn where the web browser displays errors to the programmer. This process is known as debugging, and it's a big part of programming. This might all be sounding quite negative, and you haven't even written your first line of code yet. Well, it's not. Coding is about trial and error, and challenging yourself to achieve complicated and intellectually demanding things. That is really exciting and very rewarding. There is little better feeling than getting a complex piece of code to work. One last thing. It doesn't matter how long you've been coding for. You never stop learning to program. And the more you do, the better you get. It's our goal, at the end of this module, you'll not only have learnt the fundamental skills of programming, you will also have developed the mindset to carry on growing your programming skills throughout this course and your future careers. Hi, in this video we're going to look at the most basic parts of a program and introduce the language we're going to be using during this course. Commands are the smallest building blocks of your program, a single instruction to the computer to perform an action. For example, that might be a command to draw something on the screen, to store some data, or even a command that decides which command to run next. A program is a collection of these individual commands put together in the right order to solve a problem, complete a task, or maybe interact with a user. The collection of commands you write for your program is called source code, or more normally, just code. Writing a program is the process of entering commands and saving them to a file on the computer. It's important that our commands are exactly correct and that they are in the right order. Unlike a human language, where we can express ourselves and how we feel, programming languages are dumb. We have to be very precise in specifying exactly what we want our code to do. You write your programs in an application called a code editor. Unlike a standard word processor or text editor, a code editor helps you to write code by making suggestions and spotting errors. There are lots of code editors out there, but for this course we're going to be using the brackets editor. Simon is going to show you how to use brackets in the next video. When we have finished writing our program, or more likely written enough to test what we have done so far, we can run it. Sometimes running a program is called executing. If you use Windows, you might know that programs end in .exe. This is short for executable. With the code you will write in this course, executing it is as easy as clicking a button in brackets to launch your web browser. In other programming languages you might have tried, things can be more complicated. A programming language sets the vocabulary for the commands we can use in our programs. When we say we are coding in a specific language, we mean we are instructing the computer with the dictionary of commands the language provides. The computer will interpret these commands and convert them into binary instructions that its specific hardware understands. The language we are going to be using is called Javascript. Javascript is very powerful but relatively easy to learn. It's the language that powers the web and is one of the world's most popular. Many websites and applications make extensive use of JavaScript, such as Google Docs, Hotmail, and Coursera. Along with JavaScript, we'll be making extensive use of a library called p5.js. A library is a collection of code written by someone else that we can use in our programs. By using a library, we avoid something programmers like to call reinventing the wheel. This means we avoid a lot of the boilerplate code to make our programs work. Libraries such as p5.js are a vital part of modern coding and allow us to develop more complicated programs. p5.js is designed for beginners to get into coding and focus on the important parts of their program. It's designed to help make graphical JavaScript applications and animations. Using p5.js is a lot of fun, and you can see in a visual way what your code is doing and how programming works. A good place to start learning about p5.js is the project's webpage. Let's take a look at the website now.
In this video, I'm going to show you how to run your first sketch and edit it using the brackets IO editor.
Now the first thing that you need to do is download the example sketch from the Coursera platform. I've already got one here on my laptop. The next thing you're going to need to do is to extract the file because it's a zip file. So if you're on a Mac, all you need to do is double click the file and the folder will open. On other platforms, you might need to do something different, but in any case, you won't need to download any extra software to do this. Okay, so looking into the folder, we can see that there are 3 files, and I'm going to talk you through these files now. The first file is an index.html. We have this because every p5.js sketch is actually a web page, and we're going to use this to run our file in a moment.
The second one is the p5.min.js file. This is where all the library code for p5.js is stored. And the final file is the sketch.js file, and this is the only file that we'll edit during our time on Intro to Programming. The important point is that we need all three files to run our sketch, and they need to stay in this folder. Okay, I'm going to show you a quick way to run a sketch. The way we do this is we go to the index.html file, and if you're on a Mac, you can do a contextual click and you can choose Open With, and you can choose your favorite browser, be it Chrome or Safari or Firefox, and open the index.html file with that browser. And there we go, we've run the sketch. But actually, what we're going to want to do is we're going to want to edit our sketch.js file. And for that, we're going to need to do a couple of other things. Now, you might be tempted to open this file with something like Word or Notepad or TextEdit, but this would be a really bad idea. These programs are not designed for editing code. To edit code, we need to download a specific code editor, and the one we're going to use is called brackets.io. You can find it by going to brackets.io, and it's an open source free software, and you can just download it by clicking this button. The install procedure should be pretty simple no matter what platform you're on. Okay, once you've downloaded that, we need to open your sketch, and there's a specific way in which you need to do this. So the first thing you do is actually open the brackets editor. Once the editor's open, you're going to find probably that you get these default files, but we're going to ignore these. The next thing we need to do is not open an individual file, we need to open the whole folder for the p5.js sketch. There's two ways to do this, I'm going to show you both. The first way is that you simply drag the folder into this bar on the left, and there the sketch is open. The other way you can do it is you can go to the File menu and you can go to Open Folder, and then you can navigate your way to the p5.js sketch. So here it is on my desktop, and I can open it. Once you've done that, you can access your free files there. I'm going to click on sketch.js because that's the one we're actually going to edit. Okay, so there's another way of running our sketch, and that's within the brackets editor. And the way you do this is you click the lightning symbol on the right-hand side of the screen. This now opens what's called a live preview, and this operates slightly different from when we just clicked on the index.html file. Let me show you how this works. I'm going to make some changes in my code. So what I'm going to do is I'm going to change the background color. We'll go into how this works in more detail in later videos. I'm just going to change the color now from black to red. And you can see as soon as I made the change, we could see the change happening in the live preview window. I could make some other changes as well. I'll try moving the rectangle by changing this number. Okay, so there's a couple of things that might go wrong whilst you're trying this process as well, and I'm going to talk you through some of those now. One of the things that might happen is that you end up editing the wrong file. To show you this, I'm going to need to make a copy of my sketch. So we have two sketches here. I'm going to open the brackets editor, and I'm going to start the live preview. And whilst that live preview is running, I'm going to also start working on a second file. So now I have two sketch.js files. And what happens, I'll start making some changes, but we don't see anything changing in the live preview window. And the reason we don't see anything is that we're actually working on the wrong file. So watch out for that one. Another problem that can happen is that you open the file the wrong way. So if I close brackets again, and I'm just going to try and open a single file. So I'm going to open just this, and I'm going to go open with brackets. And when I try and run the sketch, I'll get this live preview error appearing. And that's because I haven't opened the folder with all 3 files. I've just opened the individual file. And so I won't be able to run my sketch. The correct way to do it is to drag the whole folder in. And then when I run my sketch, it will be able to run. The final error that you might find is if there's something wrong with your code. So I'll make a small error in my code. And then what you'll most likely see is just a blank white screen. Okay, when you see that, you probably know that you have something wrong in your code and you're going to need to fix that before you can view your sketch. We're going to deal with how to do that in a later video in this topic. Okay, so we've run some programs and now it's your turn to start writing your own. Now, on this course, we're going to work with 2 methods for writing programs. The first is writing code from scratch, essentially starting with a blank page. And the second is to learn by hacking. Now, when coders talk about hacking, they don't mean breaking into emails and bank accounts. Rather, they mean playing with and adapting existing code to create something new. Coders might also use the word to imply roughly written code, or code that's been written with a poor understanding. But nevertheless, hacking is a great way to learn. It's an exploratory process. You might not understand the code at the start, but you'll adapt small parts of the code to gradually work out what it's doing. You might see if you can break the program, and then see if you can make it work again. And finally, when you're done with that, you'll study those bits that you don't understand. You'll look up those commands that you didn't know in the P5.js reference, and you'll reflect on any unexpected outcomes and try and work out what happened. Okay, so I've got some example code here ready to hack, and so I'm going to just give it a go. The first thing that I might try and do is just try and change some of the numbers here and see what they do. So I've got this command triangle, and I'm just going to try changing these numbers. So I've got 18. Let's make it a lot bigger. Maybe I'm going to make it 200. Okay, and then I could see there that this triangle shifted across. Maybe I'll just put it back again, and it shifted back. Yep, I've confirmed that. So I wonder if I change now the next number. Let's make that one different as well. Okay, and we see another change there. One thing I should point out is that sometimes you can see I'm pressing this refresh button. So sometimes if I don't see a change happen with the live preview, I just press the refresh button and it will come through. Okay, I'm going to change another one here. That was a very small change. I couldn't see much. Maybe I'll try a much bigger change there. And we can see that that corner of that triangle has gone off the screen now. So another thing that you might do then is if you get something, you get to the point where it's a bit broken, we can always just use the undo function and get back to what we started with. That's a totally fine thing to do. Okay, so that's one idea of how we could hack. Another thing I might do is just trying commenting out code. So if I put 2 slashes in front of the code, you'll see it goes grey, and that means it doesn't work anymore. And that can just establish what shapes are being drawn where. So I can see that that one quad is actually this shape here, or if I do this one, that's that shape there, ellipse. Okay, so I start to understand what these different commands are doing. I might also try copying some of the commands and then changing the numbers. So I'm going to copy this one ellipse. I'll make a few copies, and then I'll just try changing the numbers a little bit and see what happens. Okay, so I start getting some multiple ellipses here. Maybe I'll change that number as well, and we can move them around and start arranging them. I haven't yet experimented with these numbers. I wonder what these do. Okay, let's make it quite a big number. Okay, that seems to change the width of the ellipse. And this one, let's try that one. Okay, and that changes the height. So I'm gradually developing an understanding of what these different commands do. Okay, so that's the basic approach to hacking. Now it's your turn. Have a go at the Hack the Robot sketch on the platform.
In this module, we're going to be making a lot of graphical programs. But before we can do that, we need to understand a little bit about how the computer screen is organised. If you were to look at your computer screen really carefully now, you'd see that it's actually made up of lots of tiny little points of light. Each one of these points is called a pixel, and they're arranged on the computer screen in a grid. In p5.js, we're going to create an area of those pixels on the web page that we can draw to. And we call this the canvas. When we create a canvas, we need to give it a width and a height. This is the create canvas command. And you use it in p5.js to create that drawing area. You'll notice that in brackets after the words create canvas, there are two numbers separated by a comma. The first of these numbers is the width of the canvas, and the second is the height. The other thing to remember, as always, that at the end of any command there's a semicolon, and this tells JavaScript that we've reached the end of the command. Okay, let's imagine that the grid that you can see on screen here now is that canvas. It's 20 pixels by 20 pixels. We've magnified this nice and big, but actually on screen that will be very, very small. Smaller than a file icon and not really usable in any practical way. But it'll help us to explain what's going on. The first thing you'll notice is that the numbers run from 0 through to 19. This is a common convention in computing that we start counting from 0. An easy way to remember this is that an X makes a cross shape and the pixels go across the screen. We always start with the X coordinate and then the Y coordinate. This is kind of similar to the kind of things that you will have seen in maths at school. And the formal name for it is a Cartesian coordinate system. Okay, let's start looking at some possible addresses for some different pixels. Let's start with the top left. And this pixel up here in red is 0, 0. So an X of 0 and a Y of 0. If we move across to the top right, we have an X of 19 and a Y of 0. If we move down now to the bottom left, that's pixel 0, 19, because we haven't moved across on the X, but we have come down 20 pixels on the Y. And finally, the bottom right, which is 19 pixels across the screen and 19 pixels down. Okay, let's look at some pixels now in the center of the screen. So 9, 9 will be round about in the middle, 9 across and then 9 down. 17, 3 will be up towards the top right corner. And then the final one, well, 7, that's okay, we can come across 7 pixels, but if we try and go down 21, we're going to be outside the bottom of the screen. Now p5.js will still draw that, it won't give you an error, but it's something to watch out for, that in fact when you can't see what you're expecting to be drawn, it's just outside the bottom of the screen. So, while drawing points to the screen is quite nice, it's not hugely useful. So now let's look at drawing something a bit more practical, a rectangle. So the first thing we need to do is establish where that top left corner of the rectangle is. So in the one that you can see on the screen at the moment, it's at 5, 3. So that's 5 pixels across the screen and 3 down. As well as knowing that top left corner, if we know the width and the height of the rectangle, then we have all the information that we need to be able to draw it. So if you look at this one on the screen now and you count the squares across, you'll see that it has a width of 11 pixels. It's also got a height And in this case, it's 8 pixels. Now we've seen that in theory, let's look at how we'd actually draw that in p5.js. We can do this using the rect command. And it has 4 parts to it in the brackets. That's 4 arguments that tell p5 exactly what it is we want to draw. The first argument is the x. The second argument is the y. And that's for that top left corner. We then specify the width and the height of the rectangle. Here's a practical example of this in red, where we've actually replaced those placeholders of x, y, width and height with numbers. And this rectangle is going to be drawn at a top left corner of 100, 100, and it's going to have a width and a height of 200. Therefore, it's a square. Okay, let's now try this out in a real p5.js sketch. Hopefully by now you've had a go at running some applications, but you probably won't know how this code is organized. You've got 2 functions as in the basic template. You've got one called setup and one called draw. And now we'll get into exactly what a function is in a few weeks, but for now just know that we're going to create our canvas in setup and we're going to put our drawing commands into draw. So let's create a canvas and let's make it 500 by 500 pixels. That's going to take up about 1/4 of the screen, so seems like a good start point. It's not going to be too big, but hopefully not too small either. So now let's put a rectangle on this canvas. So I use the rectangle command, rect, and let's just put it at the top right corner to 100, 100. So that's going to be 100 pixels across on the x and 100 pixels down on the y. And for symmetry, let's make it 100 pixels big in both directions. So it'll be a nice smallish square. We save that and then run the live preview, clicking this button up here. And that'll launch our browser. And great, we've now got our first bit of P5 drawing code working, a simple square on the canvas. Now let's put a second square to the left of the first one. So this one was at 100, 100. So if we do it 100 across plus the 100 for the width of the first square and then another 50. So let's go with 250 across, same height down the y coordinate. So 100 and make the width and the height the same. We save that and then our live preview will automatically update and we have 2 squares sitting nicely next to it. Okay, over to you. See if you can draw some more rectangles to the canvas.
This week's code philosophy is about what it feels like to code. The first emotion you might experience is frustration. And that's because coders spend most of their time dealing with things that don't work. In the movies, coding is portrayed as fast, but it's far from it. Grand Theft Auto took more than 1,000 people 3.5 years to create. It would take an individual 40 years to do it by themselves. In the games industry, 18-hour days are quite common. You might be thinking, but people said coding is fast, coding is simple, coding is easy. They showed you hackathons, fancy graphics, robots. So you might be thinking to yourself, am I stupid for finding this so difficult? And the answer is no. Let's face it, coding is hard. But it's okay, don't despair. Coding is also highly addictive. Coders seem to love their jobs. So why is that? Well, coders feel empowered. They build their own machines. They teach themselves new skills all the time. And they have a unique insight into how the world works. Coders are also optimists. They always assume that they can solve a problem, and they almost always do. When they can't, they work around it. So coding is something of an act of faith. Coders don't get frustrated with problems. They master a Zen-like patience. They view each problem as an opportunity to learn. Time spent solving a problem is never time wasted. The best concept I can think of to summarize the emotional state of a coder is flow. Musicians are often said to be in flow when they're performing and practicing. Flow is a psychological concept in which you feel intensely focused on the present. You feel mastery over your actions and you experience a shortening of time. You feel intrinsically rewarded by what you're doing. And coders do the same. Here's a quote from Vikram Chandra. "The work of making software gave me a little jolt of joy each time a piece of code worked. When something wasn't working, the world fell away, my body vanished, and time receded. 3 or 5 hours later, when the piece of the problem came together and clicked into a solution, I surfed a swelling wave of endorphins." So, the mantra for this week's code philosophy is code in flow. Okay, so I've got the Sleuth app opened already. You can find that at the top of your Coursera page as well. Once you've got it open, you're going to see 3 options. You're going to see how am I doing. So if you click on that, you can see what your current score is and how many cases you've attempted and so on. You'll also see About Sleuth, which gives you just some general information about the game. But the one we're going to look at now is Let's Solve Some Crimes. So when I click on that, I can see all the cases that are available for me to solve. At the moment, the only case that's available here is case 101, the case of Lena Lovelace. When you do this, you'll actually see more cases available than that. But we're just going to start with this one, and we're going to start with the first stage, Central Station. So you can see there's actually 4 stages here, but we can't yet attempt the later stages because we haven't solved Central Station. So I'm going to click on this, and now we can see that we've got a button in order to download our crime. So I'm going to download it. And you should get a zip file probably either on your desktop or in your download folder. So I think mine has appeared in the downloads folder. And the next thing I'm going to do is I'm going to unzip that file. If you're on Mac, you should just need to double click this file. But if you're on Windows, it should be pretty simple to extract the file, and you shouldn't need to add in any kind of proprietary software in order to do this. Once I've got that folder unzipped, you'll notice that it's actually just a regular P5.js sketch like the other sketches you've been working with. So the next thing we need to do is to open this sketch in the brackets editor. Now remember to drag the whole folder in. Don't try and open just the sketch.js file. You won't be able to run the code. Okay, once I've got that loaded and I'm looking at the sketch.js file, the first thing you might notice is that there is an officer written here. My one has this name, but you'll have something else written there, and a case number. It's really important that you don't delete this text or modify it in any way. This is the text that Sleuth uses in order to grade your code. The next thing you get are some instructions. So these instructions tell us a little bit of story, but they also tell us what we need to do. So in this case, we need to draw a rectangle around the image of Lena Lovelace. So if I look at the image that's part of this package, so we've got image.jpg, I can see there's Lena Lovelace standing in the middle of the scene, and I'm going to need to draw a rectangle around her. If I look back at the instructions as well, it says that the rectangle should surround Lena as accurately as possible without including anything else. So I'm going to need to get this rectangle really close to the edges of the drawing. And it also tells me what commands I need to use. So in this case, I need to use the rect command. Okay, so I'm going to run the sketch and see what we've got so far. Okay, so far I can just see the image. So the next thing I'm going to do is try and draw the rectangle around Lena Lovelace. So now there's a really useful tool in the brackets editor where if I click on just the image and I move my mouse over, you can see that you get the X and Y coordinates of where the mouse is. So this is going to allow me to get my rectangle accurate really quickly. So I'm going to be very carefully choose this point. So X here is 432 and Y is 163. I'll say again, when you do this puzzle, it will be different. It won't be the same coordinates. So I'll just get these coordinates in my head again. 432, 163. Okay, I'm going to use the rect command that you've just learned. And in the X parameter, I'm going to put 432. And in the Y parameter, I'm going to put 163. So that will put the top left-hand corner of the rectangle in the right place. But I don't yet know what size it should be. Nevertheless, I'll just take a guess and I'll say that it's 100 wide. And I know that it's going to be a bit taller than that. So I'm going to put 200 for the height. Okay, so I save my sketch and I see how it's updated. Okay, so now I can see a rectangle there, but I can see that firstly, it's definitely not wide enough. So I think I could make the width probably 150 and that might work. So let's try that. 150. Okay, that's wide enough, but now it's not tall enough. So I reckon that could be 300. Let's see how that works. Okay. So now I've surrounded Lena Lovelace. I'm not sure whether it's accurate enough yet or not, but I'm going to give it a go. I'm going to upload my sketch and see whether it gets accepted or not. So to do this, I go here to the select the sketch.js file and I hit browse and I navigate to my project and I select the sketch.js. And if that's worked, you should see the case number appear in this window here. So then I just hit the submit solution and my code's going to be graded. Okay, so it tells me that I correctly identified Lena Lovelace. So that was accurate enough and I got 100%. That's great. So now I can continue and I get a message from the chief. So I've passed the first stage and now I'm told not to let her out of my sight. Let's see where she heads next. So now I can see that the central station stage has been solved. I could go back and try that again if I just wanted to for fun, but now I'm on to the next stage, small talk speakeasy. So I'm just going to show you a little bit of this and then we'll stop and I'll leave you to it. So I'm going to download the crime. Okay, so I've downloaded the sketch. I'm going to now unzip it again. And when I look in here, I can see, just as before, it's a basic P5.js sketch. So all the puzzles are going to be like this. So I go to the brackets editor and I carefully drag the whole folder in there and open up the sketch. And I can see now I'm on stage 2, the small talk speakeasy. And I can read the story. And now I find that I have some more instructions. I've got to do more than one thing. It says first I have to identify Lena by drawing the rectangle with a blue outline around her. So this is a little bit harder. And then I have to identify the woman with the cigarette and the feathered hat. And I have to draw a rectangle with a green outline around her. Now, I'll say this again. This puzzle will not be exactly the same as the puzzle that you get to solve. It will be very similar, but you might find that the positions are different and the colors of the outlines are different in this case. Okay, so I've got two commands that I can use, rect and stroke. So I'm going to get started, but I'm not going to get the whole way through this one. So let's have a look. Okay, well, I can see the woman with the cigarette and I can see Lena Lovelace. I think I'm going to start with the woman with the cigarette. So I'm trying to get all of her in here. So that's X is 143 and Y is 518. So I'm going to go rect 413 and Y 518, and let's just make it 100 by 100 because I'm not quite sure what the size of a rectangle should be. So we'll have a look at this. Okay, I've done something wrong because my rectangle is quite in the wrong place. So let's just go back and measure the image again. It should be, oh, X135, that's a much better number. Okay, so I'll go back and change that. And we'll have a look. Okay, so you can see I've only just captured the cigarette. I'm just going to do one more bit and then I'm going to show you some marking. So let's change the stroke color. The sketch asks for a green outline, so let's try and do that. So I'm going to go stroke. We want no red value, 255 for green and 0 for blue. So then if I look, I now have a green rectangle. That's correct. Now I know this is wrong, but just to show you how things work, I'm going to try and upload this and see what happens in the Sleuth app. So I go back here, I browse, and I make sure I select the right sketch.js file. It won't work unless you do that. And I submit the solution, and we see what Sleuth does. Okay, this time it tells us that we've partially identified the woman with the hat and the cigarette. We haven't identified Lena Lovelace, and the rectangle identifying the woman with the hat and the cigarette is too small, which you can see here, it's definitely too small. So we've got some improvements to do, and you can see that it gives us a percentage for how complete we are on the crime. So far it thinks we've done about 40% of solving this crime. So now it's up to me. I can continue and try and improve this, but I'm going to let you do that yourselves. One other thing to point out is you can see that I have only 4 attempts remaining. So if you get through all of your attempts before solving the crime, the chief will tell you that you're getting obsessed with the case and will stop you from solving it for a little while just to let you get on with some other stuff. And then if you come back to it, say a day later, you'll find that you're able to have another go at solving the case. Okay, so one more thing is now if I look at how am I doing, you can see that my score's gone up and there's some information here in the other statistics. Okay, so now it's your turn. I hope you enjoy it. So in this video, I'm going to show you how to get started with case 202, the case of Bob and Daisy. So let's go straight to it and download a crime and unzip the crime. You should know the drill by now. And the next thing I'm going to do is get my brackets open and I'm going to drag that folder into there. And let's take a look at the crime. So, the case of Bob and Daisy, a pair of notorious criminals, Woz and Jobs, are up to no good again. They've been sending letters to each other. They look like love letters from these characters called Bob and Daisy, but actually there's a hidden code. If we read these instructions, what it says is the hidden code is in red text only. So let's have a look at the sketch and see what they mean. So here we see a lovely love letter. Oh, lovely Daisy, you are my sunny day in April. From the first moment I saw your lovely face, I knew that from those few seconds you were my one true love. It all sounds lovely, apart from the fact that there is actually a dastardly hidden code there. And we can see that it's the one in the red letters. We see April, something, something, something. So we have to get this
sketch so that only the red text appears. And we're going to do that by commenting. That's what we've been told to do. This is what we must do, is we must comment out lines. We've got to only comment out the text commands. We've got to leave the fill commands there. So first things first, let's think about what is the color red. The color red is 25500. So this is not red. This is green. This is black. Let's find red. Here's some red. So these ones will have to be allowed, but all of these ones are going to need to be commented. Now I could go through really slowly commenting line by line, but I'm going to show you a really quick way of getting this job done. So I'm going to do something a little bit counterintuitive. I'm going to select all the commands and I'm going to block comment them. I can do this by going to the edit menu and going toggle line comment, or I can just use the hotkey. And everything is now commented. That's great. Now what I've got to do is I've got to look for the fill commands that are the red ones and uncomment the text underneath that. So I'm going to use the search tool. I'm going to look for fill, and let's go fill, not just fill, but fill 255,0,0, because that is the color red. And here we go. We can see the first bit of red text to uncomment. There we go, and I only go down till the next fill command because then it changes color. So let's have a look for the next bits. And I can see that there's actually 3 to find here. So this is really actually a lot easier once I start using this tool. And we've got one more to do, and that's April here. So we can now, if I look at my output, I can see my hidden code, April 2nd, a chosen date. So this is when something is going to happen on April 2nd. Now, if I look back at my instructions carefully, it also said that I had to leave the fill commands uncommented. So I haven't done the job entirely yet. But again, I can use find, and this time I can use find and replace to help me a lot. So I can find, oops, I've lost that again. Let's, where has it gone? Find and replace. So I can find all the commented fills. I think it's got, what's it got in between? This looks like, oh, it's a tab. That's a kind of annoying one. I tell you what I'll do is I'll just cut and paste it there, and I'll find all of these, and we will replace them with, I'm going to be cheeky. Oh dear, this is being slow. Let's replace them with that. Find all the commented fills. There we go. Right. So we're ready to do it. I'm going to replace them all. And ta-da! All... No, it hasn't worked entirely, has it? Let's try that again. I'm going to find all the fills with comments in front of them. Oh, tricky. And that's better. And we're going to replace them just with a plain old fill, uncommented, replace all. Okay, so my tabs have gone slightly out of place. And if I had more time here, I maybe would fix them all. But I'm going to check, can I still see my secret message? Yes, I can. I'm going to try and mark this one. Let's see how well we did there. So I select the sketch file and I submit the solution. Bam! 100% solved. You have correctly decoded the message. And we got a message from the chief. Great work, kid. Okay, now it's your turn. Okay, so in this video, I'm going to show you how to get started with case 303. That's the case of the crooked attorney. So let's go straight to Torvald's office, and we're going to download the crime that happened there. So you know the deal. Unzip the folder, open brackets, and drag the folder into brackets. Okay, and let's look at what we got here. Well, District Attorney Torvalds is well respected in Console City. He's an upstanding citizen, an enforcer of the law, but of course he's as crooked as they come. And what we have to do is we have to find some incriminating documents, and he's got them in various safes that he's hidden across town. And so we're going to have to break into them. Okay, so we've got a load of instructions, a load of commands, things that we have to do in order to crack this safe. And they seem to involve these variables, cryptic store comb A and cryptic store comb B. Now remember, your puzzle won't be exactly the same as mine, so your variable names might be slightly different. Your instructions here might be slightly different. You can't copy this video exactly. Okay, so first things first, let's run the sketch. Okay, and we can see our safe here. I was thinking maybe it's interactive, but at the moment, nothing happens. So let's try and crack this safe. Let's see what we need to do. I'm going to do a little bit of it now, and then maybe we'll try and mark it. So when the mouse button is released, so we need an event for the mouse button release. Let's have a look down here. Oh, look, mouse released. Let's just see that working. So I'm going to open the console. There it is at the bottom, and you can see mouse moved happening. Let's just try for mouse released. So mouse pressed, mouse released. So what do we have to do? We're told when mouse button is released, make cryptic store comb A equal to 16. Here's a little tip. Copy the instructions into your code and comment them. That way, it's so much easier. You don't scroll up and down the whole time, and you can really error check. Well, it's good coding practice. So this is all we have to do. Now cryptic store comb A is 16 when we release the button. Let's see what that actually does on our sketch. So I'm going to refresh that sketch. Did you see it's moved to 16 when I release the button? Let's do a couple more. Cryptic store comb A is equal to 5 when the mouse is being dragged. Let's look, mouse dragged. And again, I've copied and pasted this here. And oops, don't do that. Cryptic store comb A equals 5 when the mouse is dragged. Let's try that. So I'm going to go back to my safe. So I release the mouse and it's 16. I drag the mouse and it's at 5. Cool. So we've done 2. I'm going to do one more for you, and then I think you can work out how to do the rest. So when any key is pressed, cryptic store comb A equals 22. So let's go to key pressed, and we go, oops, cryptic store comb A equals 22. So let's try that. And I'm going to press a key. You can't see me pressing it, but I'm pressing it. And you saw it equal 22. I press and release the mouse, it goes to 16. I drag it, and it's going to 5. Cool, so we've done a few of the instructions now. So what I'm going to do is I'm going to grade that and see how I do so far. So find the right sketch. There we go. And let's submit the solution. And we can see it's still not solved. We've got 37.5% complete. But we've done some things here, and we've still got more. We haven't done anything to cryptic store comb B, so there's still a long way to go. Okay, you have a go and see how you get on.
In this video, we are going to work through another Sleuth puzzle. So, if you haven't already, open up the Sleuth app and click Let's Solve Some Crimes. And we're going to be doing case 201, the case of Judge Hopper. So if you click Department of Justice and then Download Crime, and that'll appear then in your Downloads folder. Just need to extract it and open it up in brackets. Okay, so we'll start by taking a little look at the sketch file. Judge Hopper has gone missing and we've been booked to investigate. We need to draw a separate ellipse around 4 pieces of evidence. So a letter opener, death threat letters, telephone, and the Algol leaflet. So if you have a look at the scene.png, you will see Judge Hopper's office with the 4 pieces of evidence on his desk. Right, so if we run this in our browser, we'll see Judge Hopper's desk appearing as it does in that PNG file. So what we can do to draw ellipses, we need the ellipse function. And if you remember, we need 4 pieces of information, 4 arguments. We need an x coordinate, a y coordinate, and a width and a height. So if we start by going to the scene.png, selecting the algol letters, we will get those coordinates. So for an ellipse, we need the center point. So that's roughly here 264,358. So let's enter that in. 264,358. And we'll just start with 100 pixels just to get us going. And that's actually not too bad. It's a little bit tight, so let's make these a bit bigger. 130, 130. There we go. So there's an ellipse around that piece of evidence. Let's now do this letter opener. So scene.png, find its center, which is probably about there. 254,236. So 254,236. And this is going to be narrow and long. So let's try something like that. Yep, that looks pretty good. So next up is the death threat letters. So let's have a look at this one. 415,292. So 415,292. And again, we'll start with 100 by 100. Let's see what that looks like. Bit too tight, so let's make these ones a bit bigger. Let's go 140 for each. That looks good. And just the telephone to go. So ellipse. And let's have a look at scene.png. 717,240. Don't forget to include the handle. So 717,240. 717,240. And this is going to be quite wide. So let's say 200 by 100. See what that looks like. Not bad. A bit too narrow maybe, because the handle's being cut off there. So let's make this one 150. Okay, that looks good. So let's upload this and let's see how we do. So we'll browse for the sketch file. Sketch.js. Open. Submit solution. Okay, and we've solved the puzzle and got 4 marks. Okay, let's look at our next case. In Sleuth, the case of the Python syndicate. That's case 301. So the first stage here is called the usual suspects. You can download the crime, which we'll put it into your downloads folder. And we can extract it from here. And copy that, drag that over to brackets. Okay, so we've got quite a lot of files here, quite a lot of PNGs, and we've got our sketch file. Okay, so in this case, we are going to be rearranging mugshots of the Python syndicate, and we're going to be doing this using variables. So if we run the sketch initially, we will see just one mugshot appearing on the canvas. Let's take a look at the sketch. Okay, so we're going to have to create a new variable for the x and y coordinates of each mugshot. One's already been done for us, so that's this one here. And we have to make sure that we're using the same style and format for the variable name. So this is going to either be camel case or it's going to be the underscore style. What we've got here is the underscore style. Yours will well, may be different because you may have camel case and you may well have different ordering or variable names. You have to be very careful and making sure that you use the right variable name. Okay, we can also see here that this one, which has been done for us, has put in the coordinates for Anna Karpinski. That's the mugshot that's in this hint. And we're going to have to create new variables and do the others. Okay, so let's start by creating one for Countess Hamilton, which is one of the other characters who appears on here. So var Countess underscore Hamilton. Now you can tell whose mugshots we need to create based on these image variables up here. So we want to create an X and Y for each of these, and let's start by doing Countess Hamilton. So Countess Hamilton X equals, now we're not sure yet, but if we scroll down here, we can see commented out is an image call for Countess Hamilton using a magic number, an absolute reference. So if I put that number in, so 11540, 115 for the X, var Countess underscore Hamilton underscore Y equal to 40. And let's uncomment this image. Now, if I just run this, we'll see the image for Countess Hamilton, but we're not yet using that variable name. So let's add that in now. So Countess Hamilton, and we can use brackets help here. It's suggesting what the variable might be. So we just select that, hit return. If we save, Countess Hamilton is still in the same place, but we've now done it using the variables. Okay, let's do another one or two of these, and then we'll try grading it and see how far we get. So who have we got next? Rocky Cray. Rocky underscore Cray underscore. Oh, so I've made a little mistake here that's going to cost me in the grading. My variable name wasn't exactly the same. Oh, and we have to change that down here too. Because if I was to run this now, we'd get an error, or at least we wouldn't see that picture. X underscore coord Y underscore coord. So let's save that. Perfect. So Rocky Cray underscore X underscore coord equals. So let's find Rocky Cray. Rocky Cray image 40840. 408 and var Rocky underscore Cray underscore Y underscore coord equals 40. Save that. Uncomment. And let's put him in. So that's Rocky Cray X coord. Rocky Cray Y coord. And save. And hopefully we should now have, yep, 3 images. So should we give this a go at grading? Now we won't score full marks here. Okay, so let's browse for the sketch file. Oops, we're in 201, that's no good. 301. Sketch file, let's click open, and then submit solution. Okay, so we've got a few marks, but it's telling us that we haven't created a variable for Lena Lovelace, Robbie Cray, or Bones, but 3 mugshots are in the right location. So we've correctly initialized 4 variables. We've got 3 in the right location, 3 in the wrong location, and we've got to create a few more variables to finish it up. Okay, this is our second case of the topic, and the case of the Slippery Minsky brothers. This is case 302. So if you download the bank heist sketch file. So let's download the crime. And let's pull it up in our downloads. So 302, let's just extract it and open it up in brackets. Okay, so what do we got in here? We've got our sketch and a scene file. So here we've got an image of the Gates' bank, and we've got a detective, and we are going to want to shine a spotlight from the detective all the way over to the Minsky brother. So if we run this sketch file, you'll see that we have a blank screen, but a spotlight where we can see some of that image behind it. So what we need to do, if we have a look in Sketch, is a couple of things. We have to edit start X to alter the starting position of the spotlight, and edit end X to stop the spotlight when it reaches our target. Make the spotlight move perfectly from you towards Sergey by adjusting the increments of X and Y. So this is Sergey Minsky in this puzzle. And then when we get everything done correctly, the spotlight should stop over Sergey. Okay, so let's have a look at the scene. And what we need to do is set where we want the spotlight to start. So that's over our detective. 829,111 is the coordinates. So 829 is all we're interested here. Width is just 829. So because we're only worried about the x coordinates, 829. And then the n coordinate is going to be over Sergey Minsky, 289,110. So 289 is all we're interested in here. 289. All right. So initialize x with the start variable is the next thing we have to do. So we've got variables here called x and a variable called y. We don't need to worry about that for now. But x is equal to 829 because that's where we're starting. And we want to alter the variable x below to animate the spotlight. So if you remember up here, it says we can use plus equals or minus equals. So as we are moving from right to left, we're going to want to reduce that value of x. So let's say x minus equals 1. So that's going to animate 1 pixel a frame, moving that spotlight from from the start position to the end location. Okay, let's see that running. Oh, let's do that so we can see it from the very beginning. So we're starting at our detective, and the spotlight is moving across the scene, and hopefully it will stop on the Minsky brother. Perfect. Okay, so that is all we have to do here. So let's take a look and see how we do for a score. So let's open up Sleuth again. Oops. Needs to be in downloads 302. Select Sketch, open, and let's submit our solution. Perfect. So we've done that one first time, no problems. You'll find in the later levels you will also need to adjust the y coordinate, and when you're adjusting the x and the y, you won't just want to use plus or minus 1 for both of them. You want to vary those values so that it moves at the correct angle.
In this video, I'm going to show you 16,777,216 colours. And we're going to start with my favourite colour, grey. Now, I've got a code example ready to go here to show you this. And the first thing I'm going to need to do is to explain the background command. So the background command does two things. It clears the background of any images that are already on the canvas, and it sets the background color. At the moment, the argument here is 255, and that will set the background color to white. If I want to set the background color to black, I can just change this to a 0. Now, if I want to get a grey, all I need to do is choose a value somewhere between 0 and 255. So let's try something like 100. And there we can see quite a dark grey. So if I want to make it a little bit lighter, I could go for something like 150. Now, the question is, why are we going between these values 0 and 255? Seems like some quite strange values. Well, this has to do with how computers store values in their memory. And the way that computers do this is that they have lots of little switches in their memory, which we call bits. And bits can only have one of two values, a 1 or a 0. And bits are arranged into groups of 8 switches called bytes. And so in this image, all the switches are set to on, and so all the values are 1. So the thing to think about here is how many possible combinations of values could we get out of 8 switches? Well, we could have this combination, or we could pick another random combination, and we could keep going like this, or we could have all the zeros as well. But how many combinations in total will we have? Well, it turns out that the answer is 2 to the power of 8. And that means 2 times 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 2. And when we do that sum, we get the value 256. That means that 8 bits of information gives us 256 possible values. Now, in computing, we never start from the number 1. We always start from the number 0. And that means that 1 byte of information allows us to have values starting at 0 and going up to 255. And so this is why we use the values between 0 and 255. Now we can go a little bit further than just working with different shades of greys. We can produce lots of different colours. Okay, so we have a single argument at the moment in our background command, but actually we can have 3 arguments. So I'm going to put in 2 extra values here. At the moment, we'll make them all 150. And we'll see we still have a grey. These arguments, when we have 3, stand for red, green, and blue. So first of all, we could try just setting the green and the blue to 0 and putting the red all the way up to 255. And we'll find we've got a red background. So then we could try, obviously, the green, and we get a green background, and we can try the blue, and we get a blue background. Now the next thing we could try is actually getting different intensities of those colours. So for example, I might want to make a much darker red. So I could go for something like a 150 on the red value, and I'll get a nice rusty red colour. I'll show you the same with the green. And here we have a much darker green. But we can go a little further. We can actually make secondary colours by mixing reds and greens and blues together. So for example, if I mix 255 of red with 255 of green, I actually get the colour yellow. And if I mix 255 of red with 255 of blue, I get the colour purple, or some people say magenta. And finally, if I mix 255 of green with 255 of blue, I get a turquoise colour, or some people say cyan. 255 of all of the colours gets us white. 255 just in red gets us red. 255 just in green gets us green. And 255 just in blue produces blue. 255 of red and blue together gets us magenta. 255 of red and green together gets us yellow. And 255 of green and blue together gets us cyan. And 0 of all the values gets us black. But we can actually go a bit further. We can start mixing our own colours by combining these shades. So let me try and get the colour orange. OK, I know that orange is a bit like yellow, so I'm going to start with 255 and 255, and that gets me yellow. But now what I'm going to do, I think it's more towards the red, so I'm going to reduce the amount of yellow, and there we get an orange colour. Or, for example, I might try a pink. Well, I know that pink is very much like red, but it's a little bit lighter. So I wonder if I start increasing these two values evenly, will I get towards the pink that I want? OK, and there I have a pink. And so you can experiment with mixing your own colours in this way. So we talked about how many colours we could get in total, and how did I get to that big number that I said at the beginning? Let me show you. OK, so we can use exactly the same method that we used when we were talking about bits and bytes to work out how many possible combinations of colours we have. We have combinations like 2550, 0255, all of these different sorts of combinations. But how many are there in total? Well, we've got 256 possible values and then 3 sets of those. And so we do the sum 256 to the power 3. That is 256 times 256 times 256. And when we do that sum, we get the value 16,777,216 possible colours. So you have all of those colours to play with. We call this RGB colour space. And there are other colour spaces as well, such as HSV or CMYK. But we're not going to review these at this time. It's quite fun to develop your own colours through experimentation, but it can be quite tricky finding the perfect shade that you want. So there are lots of really good online tools that you can use. And I've picked one to show to you. You can find it at this web address, rapidtables.com. And it's got lots of different ways of picking a colour. So you can move this pointer around to get the different shades here, and you can see the RGB colour values here. Or you can pick a colour directly from this chart. Or there's even a really long list of different shades that you can pick from to base your colours on. So that's it for RGB colours. Have a play yourself, experiment with the background command and creating your own colours. Now that we've learnt to control colours, let's change the colours of the things that we are going to draw. So we've got 4 commands to do this: fill, no fill, stroke, and no stroke. I'm going to start by showing you how fill works. So I've got a sketch here, and it's drawing some shapes on the canvas, and you can see that they're all in black. So what fill does is it changes the inside colour of the shapes. I'm going to use it first of all just in the setup function. So I'm going to set fill to a red colour, so I'm going to go 25500. And you can see it takes exactly the same arguments as background. And there we can see we now have some red shapes. I'll do another couple of colours just to show you the difference. And there we have yellow. And I'll try a blue. OK, now we can also change it so that the shapes aren't filled at all. And what I'd like you to do is look carefully at these shapes at the bottom and spot the difference. So I'm going to start with a fill of white. And now I'm going to change this. I'm going to get rid of this command, and I'm going to go for no fill. and no fill doesn't take any arguments. And now you can see these shapes have become transparent because there's nothing inside of those shapes. In fact, if I was to change the background color, you could see that more clearly. Okay, so the next thing to do is to control the colors of the outlines of the shapes. And for that, we need the stroke command. Now, this works pretty much the same as the fill command. So I type stroke, and I can put in 3 colors, R, G, and B. So I'm going to set it to a red color first of all. And just for variety, I'll set it to a blue color now, and you will see the difference. We might also want the shapes not to have any outline at all. So I'm going to take off of no fill. And then I'm going to set, instead of setting stroke, I'm going to set no stroke. And again, this command doesn't take any arguments. Just for reference, I'm just going to change the color of the shapes now so that you can see that as well. So I'll set the shapes back to yellow. And you can see they're yellow but without an outline. Okay, now you might want those shapes actually to all have different colors. And it's at this point that we move these commands out of the setup function and into the draw function. So here, what I'm going to do is I'm going to set the first rectangle to be yellow. And I'm going to do that by typing fill just before I draw that rectangle. Now currently everything is yellow, but perhaps I want the rest of the shapes to be red. So what I'll do is after this rectangle command, I'll type fill again and I'll set the color to red. So it's a little bit like fill is controlling a paintbrush that the program has. It can only have one brush in its hand at a time. And every time I call fill, it changes what the color of that brush is and then continues to use it as long as it's painting. Now this can cause some problems, and I'm going to show you the problem now. You might think that you have started by setting the color to yellow in your setup function, and that will draw your rectangle in yellow, and then you think you want the rest of the shapes to be in red. Now, can you predict what's going to happen here? Let's try it. All the shapes appear to be red, and the problem here is that the setup function runs once, but the draw function runs over and over again. So very briefly, the rectangle was indeed yellow, but on the next frame, we'd called the fill function and made it red, and then all the shapes subsequently drawn had been red. So a good rule of thumb is to make sure that you always set the color at the beginning of the draw function, and I'm going to do that now. One more thing we might want to do now is to add some different outlines to our shapes as well. So I'm going to just add a couple of outlines so that we can see that. So I'm going to set the outline here to green. And I'm going to set the outline here to blue. Again, we can see that same problem. Now our yellow rectangle has a blue outline because the draw loop has repeated and we haven't set no stroke. So if I want that yellow rectangle not to have an outline, I need to put no stroke at the beginning of my draw function. There we go, we fixed it. There's one more thing that you might want to experiment with, and that is transparency or alpha value. The way we do this is we add a fourth argument to the fill command. So I'm going to show it to you with these bottom shapes that are overlaid. I'm going to put in a fill command here, and I'm going to set the color to red, but now I'm going to add in another value here. So I'm going to start by putting this value at 255. Now 255 will mean that the shape is completely opaque. So far nothing has changed. But if I change that and make it 0, for example, the shape will be completely transparent. And if I put it somewhere in between, say 100, we'll find that the shape now has a kind of semi-transparency. And you can see this very nice effect where the two shapes are overlaid and the color gets darker. So that's a really good, interesting thing for you to experiment with. Okay, I've shown you everything you need to know about fill and stroke. So experiment on this sketch, but also try the Hackett exercise, Robot Parade.
Hi, in this video we're going to be looking in a bit more detail at the parts of your program, and we're also going to look at the program flow, so how your program is executed from beginning to end. So to start with, I've downloaded a sketch that you can find right beneath this video, and in it you'll see some basic code that you should already now be quite familiar with. We've got the create canvas command in the setup function, and then we've got some drawing going on in the draw function. Now we'll get exactly into what these functions are in a couple of weeks' time, but for now just know that these are two blocks of code that are going to be executed as part of your program. So if we click on the live preview, we should hopefully see two squares being drawn to the screen in two different colours. Now let's take a look at how these parts of the program are executed. As you might have guessed, the setup function is executed at the start of your program before the draw function is called. When setup has been completed, draw is then called repeatedly, once every frame. You may know what I mean by frame from film or animation, which is just a series of still images played together progressively over time to create the illusion of movement. And your browser does exactly the same thing. Every time draw is called is a new frame of the program. So, as well as which order these functions are called in, we also need to know what order the lines are called in. Happily, this is quite easy. They're just called from top to bottom as they would be lines of text in a book. So, this doesn't seem too complicated, but if you get it wrong, you can have some unexpected behavior and things might not look the way you were expecting them to. So, let me change this program around and you can see a little bit about what I mean. So, if rather than these two squares overlapping one another, if they were directly laid over the top and say the first one was a little smaller than the second one, whereas if I switch these two squares around, turn them back to the way they were originally, and neaten up my indenting, there, now we can see the two squares back as we expected them to be. One other trick you can try, thinking back to one of Simon's earlier videos, is that you can set an alpha channel on one of these colour values, and that's going to make it slightly see-through. So if using this example again, we just add an alpha value of about 100 to the blue square, this is going to make it about halfway to see-through. So if we save this and look at the sketch behind, the blue square looks purple because it's a combination of half of the blue colour with the red colour shining through beneath it. Hopefully by now you are completely bored with drawing rectangles. So in this video we're going to look at some different shapes. So I've got a sketch here which you can download right below this video, and in it if you run it with live preview you should be able to see some circles, an ellipse, a line and a triangle. So we'll skip over the rectangle for now. Hopefully you're comfortable with how that works. And let's look at an ellipse. The ellipse command is made up of 4 parts, just like the rectangle command. But this time, rather than the x and y coordinate being the top left corner, it's the center of the circle. And that provides us with the x and the y. The width and the height is the same. It's the total diameter. So with a circle, those 2 values will be the same. If we want to squish that circle down and make it an ellipse, we can do that just by changing either the width or the height. So if we change the width, it's going to make it a... Sorry. So if we change the height of that ellipse, it's going to make it squished and oblique that way. And if we change the height, and if we change the width, it's going to squish it in and make it long and thin and tall. If we have a look at this in code, you can see here I've got 2 ellipses. The first one is a circle. As you see, the width and the height are the same. And that's drawing this one down here in the bottom left. And an ellipse up here, which is stretched out lengthwise, so it has a longer width than it has height. Right, on to our next shape, and that's a line. This is the command to draw a line, and it's got 4 arguments. This is 2 pairs of x and y coordinates. So the first x and y coordinate, x1 and y1, are for one end of the line, and the second pair, x2 and y2, are for the other end of the line. And if you think about it, you can put these at either end. It doesn't matter which one's first or which one's last. You're always going to get a line between those 2 points. Back to our code, and let's look at the line command. You can see here that the 2 x coordinates, so x1 is 250 and x2 is 250. So that means that across the screen, both points are going to be aligned. So this is going to give us a nice long vertical line right down the screen. If we were to change it round, so let's make 50, 250, 450, and 250. We save that. Now we get a horizontal line right across the center of the screen because those 2 y coordinates are the same. If we wanted to make the line diagonal, then we wouldn't have that symmetry between the x and the y coordinates. Right, so our final shape for today is the triangle. And this is made up of 3 pairs of coordinates, 1 for each corner of the triangle. So the first pair are x1 and y1, then x2 and y2, and then finally x3 and y3. The great thing about a triangle is it doesn't matter which order we put these in. We can cycle them round and we will still get exactly the same triangle. As well as switching round the coordinates, using this method we can also draw any type of triangle that we want, whether that's a right angle triangle or an irregular triangle. Back in the code we can see how this triangle command works. It's the word triangle followed by the 6 arguments for the 3 pairs of coordinates. Okay, we've got one last shape on this. We've got a point. Now, you probably can't see the point on here, but it is there, and if I zoom in... So, what can we do to make this a bit clearer? Well, P5 also gives us a stroke weight command. So, if I, just before I draw that point, if I type in stroke weight, and then enter a weight in pixels, so let's say 5, hopefully that will make our point nice and visible. Let's do that, and well, we can see that the point has got nice and big, but it's also made all the other strokes of all the other shapes quite big, and that wasn't what we wanted. So we need to change it back down to a stroke weight of 1. So right after the point command, go stroke weight 1. And yep, that's changed it back. Now you may be thinking that, hang on, point was the last thing that we drew to the canvas in the draw function, so why is it drawing all the others with this heavy stroke weight? And it's because draw is being called over and over again. So even though stroke weight was being set on line 19, right down the bottom, the next time the draw function is called, that stroke weight is still valid. So P5 retains that state. So it's only when I've set the stroke weight back down to 1, even though it's right at the end of draw, the next drawing command for rectangle, that stroke weight persists then. Okay, now you go away and have a play with these different shapes, change around some of the values and draw some of your own.
By now, many of you would have encountered this situation. You've written a whole lot of code, but all you can see is a blank white screen on your canvas. And the reason for this is that you probably have an error in your code. And it's at this point that we reach for the console. The console is a powerful tool that allows you to see what your program is doing under the hood. So in this video, I'm going to show you how to open the console in 3 browsers. I'm going to show you in Chrome, Safari, and Firefox. Okay, so let's look at how to do this in Chrome. We go to the View menu, and we go down to Developer, and then we go to JavaScript Console. You can see that there's a hotkey there as well, which gradually you'll probably learn and use instinctively. Okay, once the console opens, you'll see several tabs here. Elements, console, sources. There's more here on mine that are hidden. They're shown here. And the one you want to select is console. Okay, I'm going to now show you how to do this on Safari. So if you've not enabled the developer menu on Safari, that's the first thing you're going to have to do. Once you've done it once, you won't have to repeat it again. I'm going to show you how to do this now. So we go to the Safari menu and we go to Preferences. And in Preferences, we go to the Advanced tab. And then you go down to Show Develop menu in Menu Bar. Once you've clicked that, you'll see that the Develop menu appears up here. And there's a large menu here, and you want to go down to Show JavaScript Console. Again, there's a hotkey. And if you're using Safari most of the time, you'll gradually get used to using that. Again, we see something very similar, lots of tabs here, but the tab that we want is the one that says Console as well. Okay, I'm going to show you finally in Firefox. So in Firefox, we go to Tools, Web Developer, Web Console. And again, we can see a very similar setup here, and we want to choose the console tab. Okay, I'm going to switch back, and I'm going to carry on working in Chrome now. So our sketch isn't running, and helpfully we can see some error messages in our console. And the first one looks like the relevant one. It says, create canvas is not defined. That's strange, because I'm sure that create canvas is a command. But when I look carefully, there's something wrong with create canvas. It turns out that I haven't put a capital C here. And code really is that fussy. So if I save that now with a capital C, we'll see that our sketch appears. So problem fixed. Fixing errors in this way is called debugging. And we're going to look at this in the next video. We all make mistakes, and coders are no exception. When coders make mistakes, they call them bugs. And as long as there has been coding, there have been bugs. This is an image of perhaps the first computer bug recorded by computer pioneer Grace Hopper. The source of an error in an electromechanical computer was found to be a moth that had become trapped in its workings. So it was a bug in both senses of the word. Now, in the last video, we used the console to identify and fix a bug. This is called debugging. Debugging is a core skill of programming which takes time to master. We're going to cover some of the basics now, but it's a topic which we'll keep returning to in this course. We're going to look at two types of bugs in this video. The first is called a syntax error. It's essentially a typo. It's the most simple type of error that you can make, but there are still many different types of syntax error. So I have an example here, and as you can see, although there's lots of drawing code, it's producing a blank white screen. So we know that there is probably an error here. So the first thing I'm going to do is I'm going to open the console. And sure enough, when I look down there, I can see that there's an error. This error says syntax error, missing bracket after argument list. And we can also see some really useful information. It tells us what line number this error is on. So we can see it's on line 11. So if we scroll down to line 11, sure enough, we can see that there's a missing bracket here after the background command. So if I just insert that and save the file, sure enough, our error is fixed. OK, I'm going to show you a different type of syntax error now. So OK, again, we see a blank white screen. The code clearly isn't working. But what is wrong with the code this time? I'm going to open the console. OK, this time we get a different message, syntax error, unexpected identifier. I'm not quite sure what's going on, but we'll have a look. It's line 20. OK, on line 20, we can see I've typed overlapping shapes. I think what was supposed to happen here was that this was supposed to be a comment, and I've forgotten to put the double slashes in front of them. So I'm going to add those now and save the file, and the error is fixed. OK, let's look at a different one. Once again, a blank white screen. The code isn't working. I open the console. OK, this one says uncaught reference error. Create canvas is not defined, and it happens on line 3. So in this one, this is a bit strange because we know that create canvas is a command. We've used it before, but something's wrong with it. And in this case, this is a very common mistake that people make. They forget to do camel casing. So I've forgotten here to put a capital C for canvas. Once I change that, the code works. I've got one more syntax error to show you. Again, we get the blank white screen. I open up the console to have a look what's going wrong. And this one says missing bracket after argument list, and it's on line 13. So I look at line 13, and now this is strange because there isn't a missing bracket. And this is where we start to see the limitations of the console. So the console can't quite work out what the error is, and we now have to use a little bit of our own deduction to work out what it is. So the bracket isn't missing. That's not the problem, but something else is wrong. If I look very carefully, I can see that actually I've forgotten to put a comma in this list of arguments, and that's what's making it not work. So I add the comma, I save it, and sure enough, the bug is fixed. OK, now I'm going to look at a different type of error. I've called this, for want of a better word, an argument error. And what that means is that we're not providing the right information that a command requires. So let's run this example. OK, so here we can see some of the drawings worked, but some of the drawing hasn't worked. The program isn't quite responding as we expect. Let's have a look at the console and see if we get any more information. Okay, now we don't have any particular error to look at. We do have this one that you might find comes up on your computer to do with the fav icon, but this is not the error that we're looking for. So now we just have to try and deduce what is going wrong here. So I was expecting to see a rectangle here, and I can't see it. So let's have a look at that particular rectangle command. Now I know that this is on line 11, and here I can see the problem straight away. I've only provided 3 arguments, and we know that rectangle needs 4. And so it's an argument error. So I add 1 extra argument for the height of the rectangle, and the problem's fixed. I've got one more type of argument error to show you. Okay, now in this one, again, the drawing hasn't worked as we expected, and that's what's telling us that something's going wrong. Here I have this strange sort of almost rectangle that's gone very large. I'm going to look at the console and see if I get any information there. Again, I just get that fav icon error that's irrelevant, so the console isn't helping me. It seems to be that the problem is with this ellipse that I was drawing here. So let's have a look at that ellipse command. Okay, straight away I can see a problem, and you might come across this one yourself. In this case, ellipse expects numbers, and I've accidentally, instead of putting in numbers, I've put in text here in quotation marks. And so that's just made the ellipse command not work correctly. So all I need to do is delete each of these quotation marks, and the problem should be fixed. And there we go, problem solved. Now, we've only covered a fraction of the types of errors that you can make. So this is just a start for debugging. What I would do now is go and try the debug challenge that follows this video.
In this topic's code philosophy, we're going to be talking about how to ask questions. We have established that coding is a tricky thing to do. You'll run into bugs and problems as you code. Maybe you'll get stuck on a particular bug. You won't be able to work out the right command, or you've got stuck on a tricky maths problem. Luckily, it's a challenge we don't have to take on alone. There is plenty of help out there if you know where to look and how to ask. Coders like to help one another out. If they have hit upon a difficult problem or have worked out a new technique, they might want to share their experiences online. Perhaps they will blog about it, upload a tutorial video, or they are able to answer questions about similar issues on coding websites, such as the popular site Stack Overflow, or you can use the Introduction to Programming forum. There is an art to asking the right question. A sweet spot between asking a very general question that will only receive an equally general answer, and a question so specific that it won't overlap with others' prior experience. This is true whether you are asking a person or a search engine. Let's start by looking at the wrong kinds of question to ask. A bad question might be, this doesn't work. Can you fix it? There are lots of things wrong here. Firstly, what does it mean for something not to work? Does the program not load? Is there nothing displayed to the screen? Has some error been produced? As well as being specific about how the problem manifests itself, you also need to be specific about what it is you're implementing that is causing the issue. Perhaps it's a recent change you have made to the code that is stopping it from working. Ideally, you will be able to isolate the command that is causing the issue. You can investigate this by commenting out any new lines you've added since the program last worked, and then uncommenting each command one by one until you have found the problematic command. The worst sin of this question is asking the respondent to fix the problem. Maybe this will give you the answer you need then and there, but it isn't going to help you to learn what has gone wrong in your program and to be able to fix it yourself next time you have the same problem. A good rule of thumb is never just copy and paste code. Try to rewrite the solutions you find online to fit your specific problem. Likewise, if you are seeking help from a friend or colleague, never let them type in code for you. This next question isn't a good one either. Much like the last one, it still asks for a quick fix. When struggling with errors, always make sure you have a proper look in the console before asking for help. Very often, it will include a line number in your sketch file that will tell you where the problem is. This question is much better. It concisely asks a specific question about an error. It includes where in the program the issue is, the type of error, perhaps from the console, and it seeks knowledge, not just a solution. Be careful not to over-specify your question or make it too long or complex. It'll take the respondent a lot of their time to work out what it is you're asking and how to apply their knowledge to it. Here are some tips for asking good questions. Keep your questions short, concise, and focused on the problem. Include what changes you had made just before the error occurred. Check for errors in the browser console. It might tell you where the problem is. When students come to me with programming questions, this is normally the first place I go to. Remember to keep the question focused on the error itself, not the overall program you're working on. Sometimes it can be helpful to try and extract the problematic piece of code into a short snippet in a new sketch. The act of doing this may help you find a solution. If not, it'll be easier to ask for help with a small problem than a whole big program. The answer to the question isn't the end of the process. Maybe there are bits of the answer that you don't yet understand. Sometimes it might be okay to ask a follow-up question, but you might need to look them up somewhere else. It's important to not just take the answer to the question at face value. Reflect on what you've learned. Where else can you use the solution you've been given? Did you learn a new technique or piece of code you haven't seen before? To finish, a quote from Benjamin Disraeli. "The fool wonders, the wise man asks." Hi, in this video we're going to introduce the concept of variables. So far we have drawn our shapes using absolute values. These are fixed numbers that don't change. Now this has been fine to do our simple drawing, but now we want to start adding animations and interactions to our program. We don't necessarily know what these values will be before we execute our program. For example, the mouse's cursor, its position on the screen. P5.js provides us with some useful placeholders that we can use in our code that will be substituted for the actual values when it's run. For the cursor, there's mouse X that provides the mouse's X coordinate, so across the canvas, and the mouse Y, the Y coordinate, how far down it is the canvas. Now I'm going to show you an example of mouse X and mouse Y working in code. So if you download the sketch that is just beneath this video and run it, you will see hopefully a background with a white ellipse in the center. What we want to do is change this so the circle is going to follow our mouse around the screen. So if I change the X coordinate to be mouse X, and it's written like this with mouse with a small m and a big X, and the Y coordinate with mouse Y, and save that and go back to the live preview window. Hopefully now, the little white spot is following our mouse's cursor. One thing you'll notice in this sketch is that every frame I am redrawing the background and setting it to 0, 0, 0 or black. If this line wasn't here, or if it was in the setup of the sketch, so if I cut it from there and put it in here, so You'd think that should be fine because I'm setting that background initially and I don't want that background to change. But if I save and run this, you'll see that we actually get some slightly different behaviour and not what we wanted. And that's because we're using that background as to, in effect, clear the screen between each new iteration of draw. These placeholders are called variables, and you can think of these as areas in the computer's memory that is saving and storing little pieces of information. Whenever we want to use the mouse X coordinate, if we call that, P5 will know to replace it with the actual value that's at that moment. We're going to go back to our original template and do something different with it and look at another pair of variables that P5 provides us with, width and height. Sometimes it might be useful for us to know exactly what the width and the height of the canvas is. So here, if I wanted to make this spot, rather than being just 100 pixels by 100 pixels, I want it to be take up the whole canvas, so be across the whole width and the whole height. If I change that 100 to width and the second one to height, then P5 will know to replace those values with 600 and 600. So if I click save there we go, and we now have a circle that's taking up the whole of the canvas area. If I change the size of the canvas to 800 by 800, and we change this middle point to 400 by 400, then yep, we can see again that it's taking up the whole of that canvas area without changing the width and the height values. We can make this a little bit better, and while you haven't seen arithmetic yet properly, if I change this to width divided by 2 and height divided by 2, so the / command in your programs means to divide. So if we take the width and we divide it by 2 and the height and divide that by 2, then hopefully this will be in the same place when we rerun the sketch. There we go. And then if I change the canvas size back to 600, save it, then that circle is still in the same place and filling the whole screen. So we've seen using the mouse X and the mouse Y as a placeholder for the cursor, and we've seen the canvas width and height, but the real power of variables comes in when we can make our own. Hi, we're going to be looking at some more user events in this video. So if you go back to the follow spot application that we made last time, and if it's running, you should see a white spot that follows the mouse cursor around. We're going to extend this program now so that the spot changes color when the user clicks the mouse. So we can do this by adding another function. So we start with the word function, which tells P5 and JavaScript that we're creating a new function. And this one is called mouse pressed. And then we put our two open and close parentheses, and then our curly brackets, where we're actually going to put our code inside. It's very important that you call this mouse pressed, spelt exactly as I have there, with a capital P. That way P5 will know where to look for it when the user clicks the mouse. So what we're going to do is we're going to change the fill from all white to a red color, to 5500. Okay, now if we do this, we're going to have a bit of a problem, because if we save it and rerun, we'll see that the mouse is following, but if I push the button, it's not changing color yet. And that's because we've also got this fill in draw. So each frame, it's being reset to white. So even though the mouse is being pressed and it should be changing color, we're not seeing it because it's happening for such a brief period of time. So if we take that fill and we cut it from draw, and then we add it up here into setup, making sure we have neat indentation. Hopefully this time we refresh that, I press the mouse, and the spot changes to red, and it will stay red. Okay, so let's look at one more user event. So we've got mouse pressed, let's look at a key press. So again, function, which tells JavaScript that we're writing a new function. Key pressed with a capital P. This is called camel casing. So you'll notice that the function starts with a small letter, and then when I've got a new word, even though I haven't got a space in between it, I use a capital letter. And the curly braces. And now let's set the fill here to yellow. So the RGB of yellow is 255, 255, 0. And don't forget our semicolon at the end. We save that. Rerun it. So as I move the mouse, it's white. I click it, it goes red. If I push the spacebar, it changes to yellow. Okay, have a go at this yourself and maybe try some different colors or different interactions when the mouse is pressed or a key is pressed.
In this video, we'll start by showing you how you can make variables into easily adaptable drawings. But this is just the tip of the iceberg for what you can do with variables. Okay, so I have a demo drawing here with a tree and sun and clouds. So if I wanted, say, to move the sun, make it slightly lower in the sky, well, you already know how to do this. This would be quite easy. I just find the code here for the sun, and I find the argument that controls its Y position. And, well, to make it lower, I would need to increase this number so that it travels down this way. So let's make this 200. And, OK, so the sun's moved lower, or I could move it higher for that matter. I could make it 50 and make it high in the sky. That's OK when there's only one variable to adjust, but let's have a look at the tree. The tree's a little bit more tricky. So if I wanted, say, to move the tree to the left, I could reduce this number. But now you can see only the trunk of the tree has moved to the left. So now I need to change another number. I look, oh yes, I need to change the one for the leaves here. So I have two numbers to change. You probably could cope with that, but imagine that you had lots and lots of leaves drawn on the tree. It would start to become really annoying to do this. And so we have a solution. We're going to create a variable to control the position of the tree. So the first thing I need to do to create a variable is declare it. And I'm going to declare it with the var keyword. That's VAR. And that's telling the computer that I want to create this new variable. The next thing I do is type the name for the variable. So I'm going to call it tree pos x because it's the x position of the tree. OK, that's great. The next thing I need to do is actually initialize the value. So I declare my variables up here at the very top of the sketch. Declare variables. And then I initialize them in the setup function. So all I do here is choose a starting value for tree pos x. So I've chosen 156 here, so I'm going to stick with that. So I'm going to put tree pos x equals 156. Now, you might have noticed, just as I was typing that a little thing happened with the brackets editor. It suggested the name that I wanted to use. This is called code completion, and it's a really useful thing. It speeds up your typing a lot, so you might want to let brackets choose the names for you. Okay, so I've declared and I've initialized my variable, but now I actually need to use it. So I go down to the ellipse commands here, and where it says 156, I replace that with tree pos x. You can see the code completion happening for me there. And everything looks exactly the same, which means that I've done this correctly. So now when I want to move the tree, it's a little bit easier. All I have to do is change this number here. So I could go 256 and the tree moves to the middle again, or maybe I want to move it to the right now, so I could put 356, and my code becomes a lot more adaptable. Okay, I want to look at a more complicated problem now. So let's have a look at the cloud. With the cloud, we actually have 3 parts here. And so first of all, I'm going to just start by declaring a variable for the cloud position. And I'm going to call it cloud pos x. It's very good to be consistent with your variable names. The next thing is I need to initialize it. So I'll have a look. I'll use the same number that this ellipse is at. And now I need to use the value. Okay, now this sort of works. So if I want to move the cloud, I can try moving it. But you'll notice only one part of the cloud moves. And when I come to try and use cloud pos x on the other parts of the cloud, I have a problem because these values aren't the same as that first one. And there's a solution here. What I can do is split these values into 2 parts and do a little bit of arithmetic in the middle of my command. So I'm going to split them first just with the values, and then I'll show you using the variable. So instead of putting 130, I'm going to put 100 plus 30. And instead of putting 150, I'm going to put 100 plus 50. As we can see, the cloud looks as it's supposed to, but now we've got these 2 numbers, I can now use my variable. So instead of putting 100 here, I'm going to put cloud pos x. And instead of putting 100 here, I'm going to put cloud pos x. And again, our cloud looks exactly as it's supposed to, but now I can change cloud pos x, and all 3 ellipses are going to move exactly as I intended. So there it's drifted a little bit to the right. Let's make it move more. You also might want to use a variable to adjust, say, the size of the cloud. And if we want to do this, we could use a different approach, which I'll show you now. So first of all, I'm going to create a variable which I call cloud scale. And I'm going to initialize this cloud scale to start off with to 1. Now you'll notice here that I've made this a decimal number. I've included a decimal point, and you'll see why I do this in a little bit. The next thing I'm going to do is I'm going to find all the parts of the cloud that adjust the size. So we've got, this is the width and this is the height, and here this is the width and this is the height, and here this is the width and here this is the height. So I'm going to multiply these each by scale. Okay, and now that work's done, you can see that, as we expect, the cloud still looks the same. But now what I'm going to do is I'm going to reduce cloud scale a bit, and we should see the parts of the cloud get smaller. So I'm going to make it, let's say, 0.7. And you can see now that the separate ellipses have gotten smaller in the cloud. So I could make them even smaller again. I could make it 0.2, and you can see they've gotten really small. So we're almost there. We've almost managed to adjust the size of the cloud. But the problem we have is that we also want those bits of the cloud to get closer together. So we're going to need to do a little bit more work. I'm going to put this back to, let's put it back to 0.7 for a moment. And I need to multiply the bits that move the clouds apart also by cloud scale. So I have here 30, and I could multiply this by cloud scale. And I have 50, and I could multiply that by cloud scale. And now we have a cloud where we can adjust the size. So I could make this cloud bigger now. I could make it 1.5 times bigger, and you can see everything is adjusted perfectly. Or I could make it really small. I could make it half the size, and we get a cute little cloud. So you could use this approach to use the same code to make lots of clouds of different sizes, or even make the clouds grow and shrink in your sketch. One more thing I want to show you is about code formatting here. This is now looking really, really messy, this code. And so here's a nice tip for tidying this up. You're actually able to split all of these commands onto separate lines. So if I just press return here, I get something that's much more readable. I'm going to do it for each one, and you should see the effect. And once I'm done with that, I could even put some comments in here. I could say this is for X position, and I could just remind myself what these arguments do. So this is a really nice technique for tidying up your code when the bits inside the arguments get too long. So you might want to now go further and adapt this sketch some more. So have a go yourself. See if you can add some rays to the sunshine, maybe make more clouds, add more leaves to the tree. See what you can do. Naming variables might seem like a trivial or simple task, but there are many pitfalls for the novice coder. So here are my 12 top tips for getting it right. Number 1, avoid keywords. P5 needs these to run. Number 2, avoid weird symbols. Even if it runs on your browser, it probably won't run on other people's. Number 3, avoid long variable names. You're going to need to type these over and over again. Number 4, avoid joke names. When you can no longer read your code, the joke is going to be on you. Number 5, avoid abstract names. Variable names should describe what the variable is for. So if you're using a variable to store a position, call it position or pos. Number 6, use camel casing. This makes multi-word variable names much easier to read. Each new word should get a new capital letter. Number 7, use underscoring. This is another great way of making multi-word variable names more readable. Number 8, combine both methods. Together, these methods are a powerful way of organizing your variables. Number 9, be consistent. Come up with a system for naming and stick to it. Number 10, use objects. When you find yourself declaring many variables to describe a single entity, replace them with an object. Number 11, adapt your variables. When you start writing a program, it's very unlikely that you'll know exactly what variables will be needed. So don't be afraid to change your variable names as your code develops. Finally, number 12, use find and replace. It's easier and more accurate than typing manually. So far, we've been using variables to store individual values. For example, tree_pos_x, cloud_pos_x. But when you get lots of variables, there's a neater way of dealing with this, and that's to use objects. And I'm going to show you how to use those now. So in this sketch, I have lots of variables now for my tree. I have the x position, the trunk height, the trunk width, and also one for the radius. And a clue that we could combine these into an object is the fact that I've used the word tree in front of each of them. So what I'm going to do is I'm going to first of all declare and initialize a tree object. And I do this in a similar way to the way I've made the other variables. I type the var keyword and I'm going to call this object tree. The next thing to do is to initialize it. And so I'm going to do this in the setup function. Now the syntax here is slightly different. I'm going to type tree equals, and then I'm going to use the two curly braces to make an empty object. And I'll put a semicolon at the end. Okay, the next thing to do is to add the properties. And I'm going to add one property for each of these variables. And I'm simply going to take the second part of the name. So I'll start with pos_x. I type pos_x. And the next thing I do is I put a colon, that's the two dots on top of each other, afterwards. And now I'm going to set an initial value. And the way I do this is simply to type the number in here. So I'm going to use the same number as I already used. I'm going to use 256. Now for the second property, I need to separate the two items with a comma. So I'm going to add now trunk height. And again, set an initial value. Again, I'll need a comma for the next property. And I'm going to just go through and finish these off. Okay, so I have my object ready to go. One thing I should point out is just make sure you don't put a comma after the last item. So it's only, the commas are only to separate the different properties. The next thing to do is to actually use these properties in our drawing code. So I'm going to do one to start off with and show you how to do it manually. So I can see tree pos_x here, and I want to now replace it with the property pos_x from my tree object. So to do this, I'm going to delete that one, and I'm going to type tree, and then I use the dot to access the properties. And as soon as I type the dot, brackets is really helpful, and it offers me a list of the different properties that I can use. And in this case, I want to use pos_x, and so I just click on pos_x. Now, I could go through and do this for the rest of my variables in this way, but it's quite slow, and it's also likely that I might make a mistake. So there's a much better way of doing this, and that's to use find and replace in the editor. So I'm going to do this now. So I go up to find, and I choose the replace item from that menu. And the first thing I want to do is to replace any instance of tree pos_x with tree.pos_x, like this. I'm going to do it manually because the ones where I've declared those variables, I don't really want to replace those. So I want to replace this one. I don't want to replace this one. And I don't want to replace that one. OK, so I've done that one. I'm now going to go on and do trunk height. So I will just take this little bit of code and select replace. And I want to replace this one with tree.trunk height. And again, I'm going to just go through one by one just to make sure I don't replace any ones that I don't want to replace. So I don't want to replace that one. I do want to replace this one. I do want to replace this one. Likewise, no, I don't want to replace those. OK, that's that one done. Let's do the other two. And so we can see now that our object is finished, and the tree looks exactly the same as it did before, which means that this has worked. So I can now hopefully delete my variables, and the tree should remain as before. So I'll delete all the declarations here, and I'll delete the initializations there. Excellent. So it all looks as before. And now my code is a lot cleaner and a lot better organized. Finally, I might want to start changing some of these properties. So I could, for example, make the X position a different number, or change the trunk height. I could increase the radius of the leaves, or change the trunk width. Okay, so a good rule of thumb for when you should be using objects instead of just individual variables is that all of the different variables are actually describing the same entity. So in this case, it would work because it was a tree. But for example, it wouldn't work to combine the tree and the cloud into a single object. That would be quite strange. Another hint that it's a good idea to use an object is when you find that you've put the same word in front of every variable. So that might be cloud pos x, cloud size, cloud this, or tree this, all the way through. At that point, it's probably a good idea to make it an object. So far, we've stored values in variables and objects, but the values in those variables have been static whilst the program is running. So if we want to change something, then we had to actually change the code. In this video, we'll look how to change variables values whilst the program is running, and how we can use this to animate things on our screens. You might have realized by now that amongst other things, JavaScript is a calculator. We can do any arithmetic that we want to. So I'm going to show you this now. So I'm using here the text command. If you haven't seen the text command before, the way it works is the first argument is what we want to print to the screen, and we can see this here. And then we have a second and third argument for X and Y position. So let's replace this text with a sum. So I'm going to put 2 plus 2. Now, it's not going to print 2 plus 2 to the screen. It's actually going to print the output of 2 plus 2, so the answer. And there we can see that one gets replaced with 4. Let's try another one there. We'll try, let's say, 5 minus 2. And we get the answer 3. Let's try another one. We'll do a multiplication. So let's do 2 times 2, and we get 4. And let's try one more, and let's try something with some really big numbers. So I'm just going to type a random big number and divide it by another random big number. And now we can see we get a decimal output there. Okay, so we've been calling this arithmetic, but actually programmers call these symbols here that do the arithmetic operators. And in our previous sketches, we actually combined operators and variables to do some drawing. So I've got an example here. We could have our variable ypos, and we could use that to draw an ellipse, like so. And then what we did was we did some arithmetic to draw another ellipse relative to that first one. So just 20 pixels further down. And we can keep applying that process like so and get a column of ellipses. But there's an important thing here. The value of ypos hasn't actually changed. So if I now print, after running this code, print ypos to the screen, you can see that it starts at 120 and it ends at 120. So these sums that we're doing with these operators aren't actually changing the value. What we need to do to change the value is use what's called the assignment operator, which you might normally know as equals. So I'm going to change this now so that ypos actually changes. The way I'm going to do this is, instead of using all of these different commands, I'm going to just repeat this command 4 times. So currently that means that we only see 1 ellipse. But now what I'm going to do is I'm going to say here that ypos now equals 120 plus 20. And we get 1 further down. And then I could say in between here, ypos equals 120 plus 40. And we'll get another ellipse in our column. And I could go ypos equals 120 plus 60, and we'll get the 4th one in our column. Actually, you can see here that the text that we're printing has now jumped further down, and that's because we've changed the value of ypos. You can see it's 180. So maybe we could just modify this code as well and just use the variable ypos, and then we'll need to change ypos again. So ypos equals 120. I think I'm going to make it plus 100. And there we go. So we can see that we've now managed to change the value of ypos. But the thing is that this isn't a really very useful way of manipulating a variable. We've actually ended up making a lot more code than we had before. But there is a much better way, and I'm going to show you this now. OK, so we're going to use this formula. We're going to say ypos equals ypos plus 20. Now, that might seem a little bit strange to you when you first look at it. What we're really saying is make a new ypos and make that new ypos equal to the old ypos plus an extra 20. So if I put that into values, if ypos was 120, then we're saying the new ypos now has to equal 140. And then the next time we run this command, if ypos was 140, well, now it's got to equal 160. And we can repeat so on. OK, so let's try this in our code. I'm going to replace this line ypos equals 120 plus 20 with ypos equals ypos plus 20. So far we can see everything is the same. And now what I could do is, instead of putting these different lines here, I can just replace each one with this formula. And you can see that our ellipses are now still in a column. So this has worked really well. Now, this gets a little bit more exciting when we start to put things into the draw function. So I'm going to show you how that works now. I'm going to take just 2 of these lines and put them in the draw function. And I'm going to comment out all of this drawing code up here so that we've got a clear screen. OK, can you predict what's going to happen when I do this? I just need to make sure that I've set ypos here. OK, let's give it a go. So I end up with a whole line of ellipses. And that's because the draw function, if you remember, runs in a loop. It runs over and over and over again. And your program remembers the value of ypos. So each time the draw loop runs, it says, let's add 20 to ypos, and you draw another ellipse, and so they go down the screen. Now, I'm going to get us to doing some animation. So what I'm going to do this is, first of all, change the amount that I'm adding to ypos. So I'm adding 20 each time. I think now I'm just going to add 1 each time, and we'll notice the difference when I save this. So now we get this very smooth line of ellipses, and that's because they're only moving by 1 pixel each time. So I'm going to do one more stage, and this will start to become an animation. I'm going to use the background command to clear the background each time the draw loop runs. And now we can see an animated ball moving down the screen. Now I might want to extend this. I maybe want to also manipulate the X position of the ball in the same way. So I can declare another variable, var xpos, and I can initialize it here. And then I can use it in my code here. And finally, I take this little formula and I repeat it, but instead of using ypos, I use xpos. And can you predict what's going to happen at this point? Well, the ball is going to move in a diagonal line because now it's moving equal amounts in the X direction and the Y direction each time. So now I could start experimenting with how this ball moves around the screen. For example, maybe I want it just to move faster. Well, I can add larger amounts on each frame and the ball will move faster. Or maybe I want to move it at a slightly different angle, so I could make it move more on one axis than the other axis, and I'll get a different angle. Or maybe I want it to move in the opposite direction, so I could use negative values instead of positive values. At this point, you might want to try manipulating other things yourself. So you could try making variables to change the size of the ball as it moves across the screen, or perhaps even experiment with changing the colors. Have a go yourself. The commands we've been working with so far are for drawing. They either draw items to the canvas or change something about the program's state which relates to drawing. For example, the fill command changes the fill color. Now, in this video, we're going to look at a different set of functions that deal with numbers. We'll call them mathematical functions. Now, I've got my P5JS reference page open here, and we can find these functions under the heading Math. So if I click on that, it scrolls down to that part of the page. And the first of these functions that we're going to deal with is called random. So I've got an empty example here, which I'm going to work with, and you can download that too from the Coursera page. So the first thing I'm going to do is just try out this command by typing in the setup function random. And if I run this and look at the output, you'll see I don't see anything, and that's because this is a different type of function from those drawing functions. It doesn't draw anything to the canvas. Instead, what it does is it returns a number. And so to look at that number, we're going to have to use console.log. So now I'm going to put console.log, and I'll put the random in between. And if we look now at the console, what we'll see is a random number, and it will be a decimal number, and it will be between 0 and 1, because this is what random does. It returns decimal values between 0 and 1. So if I refresh the page again, we'll see it's a different number. And if I refresh it again, it will be different again. And it will keep being different. You'll notice that your values are not the same as my values. So let's use random to do something a little bit more interesting than just producing these random numbers. Let's use it to draw an ellipse. So I'm going to draw an ellipse here in the setup function. And I'm going to put it in the middle of the page. But I'm going to make its size, its width and its height random using the random function. Now, if I use this function just like this, we'd find that the ellipse was very tiny because, remember, it only produces values between 0 and 1, and that's really too small for the size of an ellipse. So we're going to need to multiply the output of these functions by a much larger number. So in this case, I think I'm going to use 250 for each one. And when I look at the output now, I see an ellipse, and it has a random width and a random height, and it changes every time I refresh the page. So we can have a bit of fun here now. Seeing as it produces a random value every single time, what I could do is I could use this, instead of using it in the setup function, I could use it in the draw function. And remember, the draw function happens over and over again. So I'm going to clear the background. And I'm going to copy this code into my draw function. And now I get this kind of cool strobing ellipse in this way. So one thing we might want is we might not want different widths and heights for our ellipse, but rather to have one random width and height so that we actually see circles. Now, in order to do this, we're going to need to assign the output of random to a variable. So I'm going to create a variable called r, and I'm going to assign it in the draw loop. And instead of using random now, I'm going to use that variable r to draw my ellipse. And so both of these will have exactly the same value. And when we look at the output, if I refresh this, we'll see now that we only get circles. There's another way you can use random as well, and it's really quite useful. So instead of providing just a single, providing no parameters, we're actually going to provide two parameters. We're going to provide two numbers. One will be the minimum of the range of output, and the other one will be the maximum. So I'm going to say that the minimum for my circle should be something like 50 pixels, and the maximum for my circle should be something like 250 pixels. And now if I look at the console output, I'll see that I always get a number somewhere between 50 and 250. So I'm going to use that code to set my variable r. And because now I have proper pixel values, I don't need to do this multiplication anymore. Oops. And now when I look at my output, I can see I'm getting perfect circles somewhere between 50 and 250. Okay, I want to show you another function, and this is the function called min. And there's an accompanying function that is called max, and you'll see that they're quite similar in a certain way. Okay, so I'm going to show you first of all the output of min. So I'll just comment out this code. And like we did with random, we're going to console.log the output of min. And min, we can't just use min with no values. We have to provide two values. We have to provide two numbers. So first of all, I'm going to put in the numbers 0 and 1. And min will output 0 in that case. And if I do it, refresh the page, it will keep outputting 0. If I put in 10 and 1, min will output 1. So you can see here it's outputted 1. Okay, I'll put in two numbers, and can you guess what min is going to output? So I put in 24, and I've put in, what's that, 11,000. Min will output 24, because what min does, if you haven't guessed it already, is it always just takes the lowest value and returns it. So you might be thinking, well, what's the point of this function? It seems a bit strange to me. But it becomes really useful when we're working with values that change in the runtime of our program. So one good example is working with mouse X and mouse Y. So what I'm going to do now is I'm going to draw an ellipse that follows the mouse using mouse X and mouse Y. So I'll go ellipse, and we'll go mouse X and mouse Y, and we'll just make it 50 by 50. So when we look at the output, this should be no surprise to you by now. The ellipse is following the mouse perfectly around the screen. Now what I'm going to do is I'm going to use min, and it's going to stop the ellipse from going any further across the screen than roughly the middle. So what I'm going to do is I'm going to make a variable called x, and I'm going to set it to mouse X. And we're going to use it here. So far, this won't really change anything, apart from we're using this variable. So we can see everything is still the same. But now what I'm going to do is instead of saying x just equals mouse X, I'll say it equals min, the minimum, either mouse X or 250. And what that means is that the x position of this ellipse is not going to be allowed to go over 250. So if mouse X was, say, 400, it would, in this line of code, be set back to 250. So let's look at what happens. Now we can see that ellipse just refuses to go across that line. So that's one way of using it. The other way we could use it is in an animation. So instead of setting x like this, I might initialize x at 0, and then I might increment it here. So I could say x equals x plus 1. And our ellipse is going to travel gradually across the canvas. Now, if we want it to stop in the middle, I could go x equals the minimum, either x plus 1 or 250. So everything will be perfectly normal until x reaches 250. And at that point, it goes, well, what's the smaller, 250 or 250 plus 1? And it will keep coming up with the answer 250. So x will never be allowed to go past that point. And if we watch our sketch, we'll see that the ellipse stops at the point when we get to 250. Okay, so I'm going to show you the other command now. I'm going to show you the max command, which does almost the same thing. And for this one, what I'm going to do is instead of making x go across the screen from left to right, I'm going to make it go from right to left. So I'm going to go x equals x minus 1. And I'm going to make the initial value of x much higher. I think I'm going to set it at 500. So let's refresh that. And we can see our ellipse traveling backwards across the page. So now what I want it to do is I want it to stop at the middle. And I can't use the min command for that because we would get a strange effect. The ellipse would kind of jump. So what I'm going to do is I'm going to use the max command. The max command just does the opposite of min. It returns the higher number. So I'm going to go x equals max, and it can either be x minus 1 or 250. And now we'll see the ellipse travels across the screen, but it stops when it reaches 250. So have a play with that yourself. There are some other really great mathematical functions that you're going to find useful. One to have a look at, which will become relevant this week in your Sleuth puzzles, is constrain. Another one to have a look at is map. In the following weeks, you're also going to find that round and floor start to become useful as well. From here, I would go to the Hack It exercise and have a go at using these functions as part of that.
Hi, so now we understand a little bit about how variables work, it's going to be handy for us to be able to inspect those values in the console. So if we return to our original template for the follow spot sketch that we did a video or two ago, we can add some variables to it. So let's say var spot x is equal to 200 and var spot y is equal to 200, and then if we use these for the x and the y value of that ellipse, so spot x spot y, so hopefully now if I save this, that spot is going to move a little bit towards the top left corner. Yep, that's good. So we're now using the spot x and spot y values to position our ellipse. So we can have a look at this in the console by using the console.log command. So this command prints out whatever we write in the brackets to the console. So let's do spot x. There. Now, if I right click on the canvas and go to inspect, Chrome will pull up its developer tools, and then selecting console from the list at the top, we should now see that every frame, every time draw is called, it's printing out 200 to us. We can make this a little bit more useful, but if we put in quotes at the start, we can put a little bit of text that just contextualizes what this value is. So let's put the spots x is. And then before we put the name of the variable, we have to put in a plus sign. And that just tells JavaScript to add the value of spot x to that string. So we save that. There we go. The spot x is 200. So this isn't hugely useful at the moment because this value never changes, and it's a value that we've explicitly set. As you start to write more complicated programs, this is going to become more useful to you. And I can demonstrate that by, if we change spot x and spot y to mouse x and mouse y. Remember, these are the built-in variables from p5.js that tell you where the mouse cursor currently is on the screen. And we change this to be mouse x, and we'll change this to say the mouse is x, and a little space just neatens that up for us. There we go. So currently it's 0, but if I move my mouse round the screen a little, go back to the console, there you can see nice whole numbers which represent where the mouse is on the screen at the current time. So that's giving you a little introduction just how to inspect the value of your variables in the console.
This week's code philosophy is about writing elegant code. Coders don't just care about what their programs do, they care about how their programs do it. Just as mathematicians search for elegance in their solutions, coders aim to write elegant code. But what is elegant code? Is elegant code concise? The artist and musician Fredrik Olofsson produces tweet-length fragments of code that produce the intricate music such as you're hearing now. It really is quite remarkable to think that these 240 characters produced this music. Such work is a masterclass in concision, but whilst it's great art, coders would not call it elegant. Is elegant code clever? The code on the left produces the maze game on the right. The visual maze rendered by the white space in the code and the maze in the game are one and the same. This is a winning entry from the 2004 Obfuscated C competition. Here, programmers compete to create the most dastardly and tortuously clever code in the language C. Now, whilst this program is certainly masterful and clever, it would fail any programmer's test for elegance. Antoine Saint-Exupéry said, "Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away." So, elegant code is as simple as it can be. Elegant code is readable. Coders aim for well-named variables, good use of objects, logical organization, and explanatory comments. Redundancy, on the other hand, is not elegant. Coders try to avoid commented out blocks of unused code, unused variables, drawn images that can't be seen. Elegant code also follows conventions. Coders make sure that they align brackets and that they indent their code between those brackets by one tab. When lines get very long, coders often break things onto separate lines. And coders like to use comments that have to-dos and fix-me's to plan their work. Now, of course, there's much more to writing elegant code than these rules alone. And as your knowledge develops, so will your sense of what is elegant code. These guidelines give you a good start. It takes some practice to use them consistently, so try to be elegant in every line of code that you write, no matter how trivial. So, this week's mantra is always be an elegant coder.
Hopefully, if you're watching this video, it's because you've now completed the Introduction to Computer Programming MOOC.
Well done, you've taken your first steps towards becoming a coder.
You've learnt how to create interactive animations using P5.js, how to work with variables in JavaScript, and how to work with operators and arithmetic.
If you've enjoyed this MOOC, you might be interested in our online degree in computer science. One of the first things you'll do on the degree is take the full version of this module.
We have many topics for you to study, many more cases in Sleuth, and you'll also create your own side-scroller computer game. So, to find out more, click this link.
Hope to see you soon. Bye.